Here are solutions to homework set number 1 for ECE 476, Advanced Embedded Systems. This is looking at just Python programming using Python as a calculator, very similar to MATLAB. On the first problem, find the resistance from A to B using Python. So to do that, what I can do is, notice I've got series and parallel. What I would do is go inside and work my way out, put these two in series, parallel, series, parallel, series. So the procedure is I start out, call this R1. R1 is 200 plus 300. R2 is that in parallel with 450. The equation for parallel resistance is 1 over the sum of the admittances. So 1 over R1 plus 1 over R2, or 1 over 450. Inverse is the net resistance. In series with 75, adds. In parallel with 250, so you take that result. In parallel with 250, take the inverse. In series, add. So the total resistance, when you're all done, is 188 ohms. So again, Python is just a calculator. Similar syntax to MATLAB. Problem 2. Find the currents using current division. Now the equation for current division is in terms of admittances. So for voltage division, I use resistance. In current division, I use admittance. So for I1, it'll be 1 over 200 over 1 over 200 plus 1 over all this mess. So what I need to do first is find the resistances looking right. So this right here, obviously, is just 400 ohms. This resistance looking right is 300 in parallel with 525. Gives you 190.91 ohms. This is 1 over 200 plus 1 over this impedance, which is 75 plus 190, 114 ohms. So now I can do current division. I1 is just 1 over 200, what I'm measuring, over the total admittance. 1 over 200 plus 1 over this mess, which is 75 plus R2. That percentage of 10, 5.7 amps. Once I know I1, I can find I2. I2 is what I'm measuring, 1 over 300 plus 1 over 1 over 300 plus this mess. So it's what I'm measuring divided by the total admittance, 1 over 300 plus 1 over 400 plus 125, that percentage of 5.7 amps. The percentage of I23, which is 2.7 amps. And then by conservation of current, I3 is just the remainder. So that's your answers. 5.7 amps, 2.7 amps, 1.5 amps. So Python is, again, a calculator, much like MATLAB. Voltage division. In voltage division, I use resistance. Current division, I use admittance. Voltage division, I use resistance. It's what I'm measuring over the total. So V3 is 400 over 400 plus 125 times V2. V2 is this impedance over 75 plus this impedance. V1, that percentage of V0. So what I need to do is find the admittance, find the impedance looking right. So this is 400 ohms, 190.1 ohms, 114 ohms. Now that I know that, I know V1 is 114 over 50 plus 114, that percentage of 10. 6.95 volts. I know that V2 is this impedance, 190 over 190 plus 75, that percentage of V1. 4.99 volts. I know that V3 is 400 over 400 plus 125 times V2, 3.83 volts. So there's your voltages. And again, Python behaves very much like MATLAB. Finally, Python does complex numbers just fine as well. And there's another way of doing this. I didn't know this until somebody showed me. I could also do 200j. That's a complex number. I can do 100 plus 200j. That's perfectly valid Python notation. I didn't know that. So I created a variable called j, which is the square root of -1. Now I can use that. So R3, that's this mess, is J200 in parallel with 100. That is 1 over R1 plus 1 over R2 inverse 80 plus J40 ohms. In series with 40, so where am I at? I don't know what this is. R2 is that plus 40, 120 plus J40 ohms. That in parallel minus J150. So that's 1 over minus J150 plus 1 over R2. Take the inverse. All this looking right is 101 minus J56. In series with 30 is 131 minus J56. In parallel with plus J100 gives you J100 in parallel with that mess. Gives you 68 plus J77 in series with 20. Gives you 88 plus J77. So there's the total impedance. So net result is Python, the command window looks just like MATLAB. You can add, subtract, multiply, divide, complex numbers. It doesn't really care. The slight difference is Python handles matrices differently than MATLAB. And Python's not a matrix language. It treats it as a string. Versus MATLAB treats matrices correctly. But we'll get to that a little bit later. But that is homework set number 1 for ECE 476.